Welcome back to my YouTube channel. In this video, what is the value of W? Given that you have W to the power of 3 plus W equals 30, then let's have it to be solution. So from here, we have W to the power of 3 plus W equals 30. Then we can have this as W to the power of 3 plus W equals, we can have 30 as the product of 27 plus 3. So from here we have W to the power of 3 plus W equals, let's have 27 in base 3 as 3 to the power of 3 plus this 3. So from here, let's regroup this by taking this one here. We have W to the power of 3 minus 3 to the power of 3 plus W minus 3 to the power of 3. Then let's set here to be equals 0. So from here, let us recall, or let's have them in parentheses as W to the power of 3 minus 3 to the power of 3 plus open parenthesis W minus 3 close it equals 0. Then when we have A to the power of 3 minus B to the power of 3, we call this difference of 2 cube. We can have this as A minus B times A square plus AB plus B square. We have it as this. By equating it with this one here, we have our A to be equals W, then our B will be equals 3. When we substitute everything here, we are going to have W minus 3 in parentheses times W square from here plus 3W plus 3 square as we have this one here, then plus again W minus 3 all in parentheses, still have it equals 0. We have W minus 3 in common. We can factor it out to be W minus 3. Then the whole of this expression to this end divided by this here. We are going to have this one left. W to the power of 2 plus 3W. 3 to the power of 2 will be 9. Then this side to this end divided by this will be 1. We close it equals 0. We have W minus 3. This will be W square plus 3W plus 10 equals 0. So from here, so when we have this, is either we have W minus 3 equals 0, or we have W square plus 3W plus 10 equals 0. So from here, we have W to be equals 3 to be the first solution. Then let's define some parameters here. Let A be the coefficient of W square, which is 1. Then let B be the coefficient of W, which is 3. Then let C equals 10. So having this as this, let us recall from the quadratic formula where we normally have W to be equals minus B, positive or negative, square root of B square minus 4AC over 2A. So now, when we substitute all this here, we are going to have W to be equals minus B is already 3. B is 3. Here will be minus 3. Positive or negative. Here will be 3 square. 4 times A, 1 times C to be 10. Then over 2 times 1. So from here we have W equals minus 3 positive or negative. Square root of this 3 square will be 9. 4 times 1 is 4 times 10 will be 40 over 2 times 1 is 2. So we have W to be equals minus 3 positive or negative square root of 9 minus 40. This will give us minus 31 over 2. So we have W to be equals minus 3 positive or negative. We can express this as root of 31 times root of minus 1. So over 2. So let us recall that when we have root of minus a always equals as root of a times root of minus 1. But root of minus 1 equals I in a complex space. So from here we are going to have W to be equals minus 3 positive or negative root of 31 times I, then over 2. So from here we can define all the value of W. We say W1 equals 3. We have W2 equals minus 3. Let's go with plus root of 31I over 2. Then when we have W3 will be minus 3 minus root of 31I over 2. So from here we have W1 to be 3, W2 minus 3 plus root of 31I divided by 2, W3 to be minus 3 minus root of 31I over 2. But mind you that this happens to be the complex solution that we have, these two answers. So if we are to verify whether the real solution here will satisfy, let's to check. It is very clear that we have W to the power of 3 plus W equals 30. Then when W equals 3, so here will be 3 to the power of 3 plus 3. This equals 30. From here we have 27 plus 3 equals 30. 27 plus 3 is 30 equals 30. So the left hand side equals to the right hand side, and this implies that this solution is satisfied. So we are new here and find this video interesting. Don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos. So therefore, finally, we can declare that our W equals 3.